I am Susan Cameron Devitt. I'm a senior data scientist at SenseCorp, and thanks for listening to my talk today. It's time for Pi, time series analysis and anomaly detection with Python. So today I'm going to share about how you might use time series analysis, why you might use time series analysis, the types of questions that you can answer, and a couple of Python libraries that are really key and very useful for doing this. One of the interesting things that you can do with time series analysis is you can start to look at trends that aren't obvious, so data that's quite noisy, quite complex. You can understand what trends are really present, what's a seasonal pattern versus an overall trend, and then the residuals, so where are anomalies or events that are kind of outside that trend and that seasonal pattern. And this is really important because it lets you know, when you see a dip in sales, is that because it's a kind of, happens to be a kind of down season and it's expected, or is it an anomaly? When you start to see, an increase or a spike in sales, is that, a true gain, or is that, again, based on a seasonal pattern? And ultimately, understanding this lets us be able to start to make predictions about rebound and recovery. So thinking about, right now, we're obviously in a really large anomaly with COVID, patterns of consumer behavior, patterns of sales, all of that is very different from what is our normal expectation. And our data can sort of help us understand, even though we're in an unprecedented time, we can still start to bound the uncertainty around our estimates based on what we know kind of inherent within our data. So these are the types of questions that we're looking at to try to apply when we're thinking about time series analysis, things about like clustering and market segmentation, things doing time series decomposition. So I mentioned that already, looking at the trend, the seasonality, detecting anomalies. And all of this is hopefully coming together to allow us to either develop optimizations or forecasts for how we think things might be in the future, and in particular, letting us kind of quantify and bound our uncertainty. So this is our machine learning pipeline for this project. This was a client project that we worked on that had almost 7 million invoice records over about 28 months of pricing history, and for almost over 450 locations for over 6,000 products. So it's a lot of data. And again, when you sort of just look at it or try to plot it or try to get kind of an average or even do sort of smoothing. There's a lot going on. And I always, whenever I'm kind of explaining this to clients, I always use the kind of apples and oranges. So it's like within this data set, we've got apples, we've got oranges, and we really want to be able to separate them out. So that's where the clustering comes in, this shape-based distance and dynamical time warp. There are other ways of doing market segmentation and clustering, but this was the approach that we took for this project. And once we do that, when we kind of understand, again, the apples and the oranges, we can then use them to actually build a model to look at anomalies, because they're going to have the same types of anomalies, the same types of trends within those clusters. And that this can be really useful for developing forecasts or for doing, modeling of recovery after some sort of anomaly. So I'm going to talk about 3 kind of use cases really briefly right now. So the first one is that market clustering and segmentation piece. And again, this is where you want to have your apples and your oranges separated. So have all 460 locations sales at all of those locations are doing kind of different things. They have different seasonal patterns, they have different trends, they have different levels of variance. And we can use a time series clustering method. And there's actually a library within Python called DTW clust, and there's two algorithms for clustering that I'm talking about here. So both of them are hierarchical clustering methods. So they give you a tree-based clustering based on similarity. But one, dynamical time warp, that's based on Euclidean distance between the two time series. You can think of like those two lines of time series going through time, and it's measuring how far apart they are, so that they have this similar sort of absolute value as well as a similar shape. Another method would be to say use a shape-based distance metric, where I'm looking to see if they have a similar shape, so similar seasonal pattern, similar trend, similar anomalies, but they don't have to have the same kind of absolute value. You know, maybe one store is really large and so its sales are quite high, another one is smaller, but they follow the same sort of pattern. So shape-based distance will bring those into the same grouping. So two sort of different methods for calculating that distance or calculating that similarity. Once you have that, and again, these are implemented in the library DTW clust. Once you have those, then we're just, it becomes a, hierarchical clustering method. We can use elbow plots to look at the optimal K, the optimal grouping size. Here we've got 7 clusters. So we went from those 459 stores down to 7 clusters. And then the clustering doesn't tell you anything per se about why they're clustered together. So you actually need to go in and look at them, plot them, to begin to understand kind of why did they come together. And so when we do that here, we see that, these 8 markets here are in this first cluster. This is sort of what this first cluster is made of. And we see that they all have kind of a similar sort of pattern, this sort of like increasing trend that maybe falls off a little bit towards the end. And this is really useful. We can start to look at, okay, so where are these clusters? What actual stores are they? Kind of why are they coming together? And once we do that, and once we feel kind of confident, again, going back to the apples and oranges, that we've got all the apples together, then we can start to do a decomposition, and then we can even build a model forecast. And so that's what this third panel here is showing. So once we've got these 8 together, we can then look at the decomposition. And again, this is within stats models, which is a really large library within Python that has a whole suite of time series models and methods. And there's several different ways of doing decomposition, naive decomposition, which is just an additive way of separating out Loess decomposition. There's a couple of different actual ways of doing this decomposition, but they all have the same basic properties, and that we're taking, this time series, or like a wave, and we are separating out the overall trend, which is shown here in blue. So the observed data is in black. We're separating out the trend, which is in blue, the seasonal pattern, that again is this sort of regular, predictive, predictable based on whatever time you want to look at, and then the green is the residual. The residual can be really important because when we see large residuals, those give us a clue about an anomaly. We can start to think about, well, why is this residual really large right here, and begin to go in and investigate it. So when we do that, what we see is when we actually go in and look at some of these residuals, we can actually tie them very clearly back to some sort of an event. And in this case here, we're looking at Hurricane Harvey in the sort of southeastern Texas, kind of Houston area. And in that case, we see this really clear anomaly that we can tie to a natural disaster. Why is that important? Well, when we begin to look at this, we can start to fit a sigmoid curve. And again, you can fit this in a variety of different statistical packages within Python. But what's important about the sigmoid curve when we're thinking about anomaly recovery is we're both interested in this lower part of the curve. So how long does it take? If we're providing insights to our customers, we want to understand how long from when a hurricane starts do you see kind of a recovery in your demand and actually an uptick in your demand. What's the slope of this? How long does it take? How steep is that slope? Because that's going to give our customer a lot of insight into how to get their product where they need to. And on what timing, and then kind of how long does it take to get back to sort of business as usual? Those are all really important things that we can detect with our time series analysis. So just to kind of recap, this type of time series analysis, and there's a couple of packages that I talked about today in Python, really lets us get a lot of insight into non-obvious patterns, non-obvious trends, and we can really improve our decision making when we do so. Thank you.